Wi-Fi. Most devices connect to the internet using Wi-Fi or wireless fidelity. It's used everywhere, from homes to offices and cafes to airports, as it allows devices to communicate over distances of up to a few hundred feet. The technology behind Wi-Fi began in the 1990s with a project aimed at improving phone connectivity. The breakthrough came when engineers at the Commonwealth Scientific and Industrial Research Organization in Australia developed a technology that would eventually lay the foundation for modern Wi-Fi. In 1997, the Institute of Electrical and Electronics Engineers released the 802.11 standard, the technical framework behind this technology, quickly making it the most popular wireless networking technology everywhere. With the ability to support devices like smartphones and laptops and other Internet of Things gadgets, Wi-Fi has transformed the way we stay connected. Ethernet. While Wi-Fi connects devices through the air, Ethernet does it with physical cables, directly linking them to the network. It's still widely used in offices and even in homes where fast, stable internet is a priority. Ethernet was invented in 1973 by Robert Metcalfe, a computer scientist at Xerox Palo Alto Research Center, as a way to connect computers in the same building. Back then, it transmitted data at just 2.94 megabits per second, and fast forward to today, Ethernet speeds have skyrocketed to 10 gigabits per second or even more. The biggest advantage of Ethernet is stability, as it provides more reliable and faster speeds compared to Wi-Fi. Because it's wired, there's no interference from walls or other devices. You get a consistent internet connection with low latency, making it ideal for most online activities. Fiber optic. Serving as the backbone of modern internet infrastructure, fiber optics have revolutionized the way we transmit data. They use light signals to send information over long distances, making the connection not only incredibly fast, but also capable of handling massive amounts of data with virtually no delay. The idea dates back to the 1960s, when scientists Charles Cow and George Hockham proposed the idea of using glass fibers to carry light signals. By the 1980s, it became a practical reality, and now, fiber optics drive most of the world's internet and telecom systems, reaching blistering speeds of up to 100 gigabits per second or more. At present, fiber is the standard in internet service provider networks. Unlike copper cables, it delivers high speeds for both downloads and uploads, even across long distances, which is why they're so important for today's growing data needs. Coaxial cable. Still used for many internet and cable TV services, coaxial cable, often called coax, is an older but reliable wired technology. It's built with a central copper core surrounded by insulation layers. The simple but effective design has kept it relevant since the 1950s when AT&T developed it for long-distance telephone lines. Coax is still common in homes up to this day, especially in areas where fiber hasn't yet been rolled out. However, it can suffer from bandwidth sharing issues because if too many users are online at once, speeds can drop across the board. Powerline Networking. This is a clever way to extend your home's network without running any new cables. Powerline Networking sends data through the electrical wiring already built into your walls. Just plug in an adapter, and any outlet becomes a network port. No drilling and no extra wiring needed. The idea dates back to the early 2000s, when engineers realized that power cables could be repurposed to create a home network. And today, it's still one of the easiest ways to expand your home network. It's not as fast as Ethernet or fiber, but it's perfect for areas where Wi-Fi struggles and rewiring isn't practical. Digital subscriber line. Back in the 1980s, DSL emerged as a way to bring internet access into homes through telephone lines. Unlike dial-up, it lets people stay online without tying up the phone line. But DSL has a key limitation as it is distance sensitive. The farther you are from the provider's hub, the slower the connection. Although it's been surpassed by modern fiber optic or cable connections in cities, it's still commonly used in rural areas or regions where faster options aren't available. It is affordable and handles everyday tasks like web browsing and email, but it struggles with activities that require high bandwidth like video streaming or large file downloads. Cellular networking. Over the years, cellular networks have evolved from simple calling and texting to delivering blazing fast mobile internet. Today, they're the backbone of wireless connectivity for smartphones and other mobile devices. These systems use a network of radio towers to send signals across regions, breaking them into cells to manage and ensure consistent traffic. The first generation, 2G, launched in the 1990s, marked a major shift for mobile phones, allowing for calls and basic texting. Then came 3G in the early 2000s, introducing mobile web browsing for the first time. But the real leap came with 4G LTE, which brought fast internet to smartphones and opened the door to heavy data usage activities. Now, 5G is taking things even further, with download speeds up to 100 times faster than 4G and more reliability. It is a game changer for activities like virtual reality and other high bandwidth experiences. Satellite internet. It works by sending data to and from satellites orbiting the Earth, making it one of the few options for people in remote or rural areas. The technology became widely available in the late 1990s, when providers like DirecTV and Dish Network started offering basic internet services via satellite. Satellite internet tends to be slower and suffers from higher latency because signals have to travel such long distances. But it's still a critical lifeline where no other infrastructure exists. Now, newer systems using low Earth orbit satellites are changing the game as they offer faster and more reliable service. Companies like SpaceX's Starlink are leading the charge on bringing high-speed internet to even the most isolated places on Earth. Bluetooth, a short-range wireless technology used to connect devices over a small distance, usually 30 feet or less. Bluetooth is perfect for things like headphones and fitness trackers or smart home devices. Unlike older tech like infrared, Bluetooth doesn't require a direct line of sight and uses very little power, making it ideal for battery-powered devices. The technology was introduced in 1994 by Ericsson to eliminate the need for cables between personal devices, and since then, it has evolved dramatically. Today's Bluetooth 5.0 can transmit data over greater distances and supports multiple devices simultaneously, making it more versatile than ever. Near-field communication. This is a super short-range wireless technology that lets devices exchange data when they're just a few centimeters apart. Because of that close range, NFC is fast and secure, perfect for things like contactless payments and transit passes. This tech has been around since the early 2000s, but it took off with the rise of mobile payments. Today, most smartphones have NFC built in, letting you pay just by tapping your phone. Its simplicity and security make NFC one of the most seamless wireless tools in everyday life. Infrared. Before Bluetooth and Wi-Fi, there was infrared, an older wireless technology that uses light signals to transmit data, but only if the devices have a clear line of sight. That's why it was perfect for TV remote controls, but not for complex networking needs. Infrared communication dates back to the 1960s, but it didn't gain widespread popularity until the 1980s with the rise of home electronics. Over time, faster and more flexible technologies took over. Today, you'll still find infrared in some remote controls and legacy systems, like medical and weather warning devices. But for most modern networking needs, it's a thing of the past. Zigbee. Another low-power wireless protocol designed for short-range communication, Zigbee allows low-bandwidth activities between devices like sensors and smart door locks. Because of its ultra-low power consumption, Zigbee is ideal for devices that run for months on small batteries. Introduced in 2004 by the Zigbee Alliance, a group that includes companies like Texas Instruments and Philips, the protocol was created to support reliable and scalable networks in connected environments. In addition to its energy efficiency, Zigbee networks can support dozens or even hundreds of devices without compromising performance, making it a strong contender for building robust smart home ecosystems. Z-Wave. Similar to Zigbee, Z-Wave is another wireless technology used primarily in home automation. It operates on a different frequency to reduce interference and extend range, thus enabling smart devices like thermostats and lights to form a mesh network that can be managed remotely from anywhere in the home. First introduced by Danish company Zensis in 2001 and later acquired by Silicon Labs in 2008. The technology is known for its strong focus on interoperability, as it allows devices from different manufacturers to work together seamlessly. While it's not as widely adopted as some alternatives, Z-Wave remains a highly secure and energy-efficient option. valued for its standardized communication and consistent performance in smart home environments. LoRa and LoRaWAN. In environments where low power consumption and long-distance communication are needed, a specialized networking technology such as LoRa and LoRaWAN is required. LoRa, short for long range, allows devices to transmit small amounts of data over several kilometers while using minimal battery power. LoRaWAN, low power wide area network, acts as the communication protocol that links these devices in a scalable, wide-reaching system. This makes them ideal for Internet of Things applications such as smart cities and agriculture, and asset tracking in rural or remote areas where traditional networks fall short. Developed by the LoRa Alliance in 2015, this technology has seen widespread adoption in industries that require long-range, energy-efficient communication. Whether it's tracking livestock or monitoring city assets, LoRaWAN is helping drive smarter and low-power connectivity at scale. Mesh networking. Instead of depending on one central router, mesh networks use multiple nodes that work together to blanket an entire area with a strong, reliable signal. If one node goes down, the others keep the network running, so you're always connected. The setup is perfect for large homes and offices, or even urban environments where Wi-Fi coverage can be spotty. It's also scalable, as you can add more nodes to grow coverage. While it feels like a modern fix, mesh networking began in military communications, where wireless networks needed to be resilient and adaptable. Li-Fi. It might sound like science fiction, but Li-Fi, or light fidelity, is a real technology being developed to take wireless data transfer to the next level. It uses light instead of radio waves to transmit data. Conceptualized in 2011 by Professor Harold Haas at the University of Edinburgh, Li-Fi works by rapidly changing the brightness of LED bulbs. Then, a photodetector picks up those changes and converts them back into data. Because it uses lights, Li-Fi can deliver ultra-fast speeds with less interference than Wi-Fi. But there's a catch. It needs a direct line of sight to work, meaning walls and obstacles can potentially block the signal. While it's still in development, Li-Fi could become a game changer in places like airplanes or crowded networks where radio signals struggle. And that's a wrap for the most notable networking technologies. Hit that like button, subscribe, and ring the bell for more tech insights.